hello everyone, and nice to see you here. And this session would be dedicated to build a mind map for you, what is going on with serverless and how you can build or not build applications on Azure. Because a lot of things going on, and today I will try to solve the puzzle for you that I'm trying to solve, that I already solved for myself. So, few words about me. My name is short Stas Stanislav. I'm from Ukraine, Odessa, working with different companies, running the user group and some non-profit communities. And this is the plan of today's talk. We start with the bigger picture, then we continue to the .NET 8 maturity model and how Microsoft .NET team trying to remove different open source components from your technical stack. Then it will be Azure Container Apps, what is working there and what's not. Then it's Azure Functions, then usage scenarios, and then it's finally obstacles. So what is not working and why you would not use anything from this list. So the bigger picture is quite interesting. A lot of things going on now, and with each and every release of different .NET components and other frameworks, we're getting more complicated stuff. So in the core of the changes is .NET framework. .NET 8 brought a lot of changes. Significant change, it's .NET Aspire that's still in preview but will be released this year. Then it's updates to the container apps that is dependent on the Dapper framework. Then it's ahead of time compilation from the .NET. Anyone heard about this? Okay. .NET Resilience. So if you use it poly framework before in your application, in your applications, you can use something from .NET now and something from the Dapper. Anyone using the Dapper in production tested? Okay, great, perfect audience. Okay, let's vote. Who is developer here? Okay, great. Any team tech leads? No. Oh, yeah, yay, cool. And I hope there is no DevOps engineers here. Hopefully not. Oh, cool. Yeah, I know the reason for this because if you're talking serverless, then it's anti-DevOps in a way. So you can live without DevOps engineers, and this is why on the farthest side from me there is a Radius project, and I mentioned platform engineering. So platform engineering is something that DevOps engineers reinvented the serverless. So developers will be doing only features and services, and the rest would be responsibility of DevOps engineers or platform engineers. And Microsoft actually with Radius project trying to solve this issue. So there is a serverless and there is a Radius. So if you can approach development from a different perspective. Radius is still like incubation project and is still in the preview, but we will talk about this. So this is the bigger picture, and let's detail it. And let's start with responsibilities. So developer responsibility in ideal world, it's serverless functions, it's functions, containers, framework, NuGet, code security, and etc. And then it's operations responsibility. And the point is now everyone, each and every company trying to remove operations from developer stack. Anyone doing operations here? Writing infrastructure as code? Okay, and development in parallel. Yes. Okay, I would say that this is like a favorite type of developers for many companies. That is a full stack. They do in front end, back end, infra, everything. But bigger companies trying to remove this, trying to make developers more productive. And if you, as developer, doing some infrastructure and some boilerplates, it's actually called shadow ops. It's anti-pattern, and companies trying to fight this stuff. So like if you team lead and receiving huge money for your effort and doing infrastructure as code, then it's probably money not very well spent from the company perspective, not from yours, obviously. So this is the responsibilities, and this is why we're talking about this. Developer comfort zone. I worked with many teams, and as a developer myself, sometimes I'm kind of keen on working with infrastructure and some boilerplate, some Kubernetes stuff, but most of the developers, from my perspective and perspective of this Sid Palace guy from the Twitter, it's actually about staying in the comfort zone. So comfort zone now it's coming from two sides, from serverless and platform engineering. And let's start with the .NET. Native ahead of time compilation. So as you know, there is a compilation of the C# code, F# code to the assembly code, and it's just-in-time compilation for any processor or any platform that you have. Now with .NET 8, they release it ahead of time compilation, and this means that it's compiled for the particular CPU and particular platform, and with no extra dependencies that come in from the system namespace. So it's quite minified. Now it's only for the console application, but this is the source of changes that will be coming with the next .NET 9 and .NET 10. So this way, a bundle of .NET application or function or any code that you deploy will be super minimal. And then we come into the container improvements. This is the size. This is the size in megabytes. And on the farther side, it's a chiseled container from Ubuntu with ahead of time compilation application. So there is no extra dependencies here, and so no extra dependencies, no extra security vulnerabilities, no extra patching of these containers. So typical container now that you're using on the Kubernetes, it contains about 50 different SDK, 50 different components. It can be from anything from Nginx to the .NET framework and system libraries. And Microsoft and Ubuntu now doing the effort in this area. And actually, they are focusing on minimizing container image side to solve serverless problem. Serverless problem, it's a cold start. And with cold starts, you have this gap up until few seconds if you start in a function, and it's even worse on the container apps with big containers. So imagine if you have container with like 50 megabytes, and it can be container with 8 megabytes only with your application. So this is what coming from Microsoft, and it's already in these containers can be used already in production. Not with AOT, ahead of time compilation, because ahead of time compilation coming for other applications later on. Only thing I forgot to mention here, because there is a variant of ahead of time compilation now. It's but we will step into this with functions. Moving further. So all my applications, like microservices, functions, and even some boilerplate, have some kind of resilience policies, but usually they are coming from Poly framework. It's just an extra dependency, and if you run an extra dependencies on your Azure Functions or any serverless code, it means that bundle size will be bigger, and it take more time for framework to load this. And so Microsoft doing all these changes in the effort to minimize the bundle and decrease the cold starts. So now you can have rate limiting, circuit breakers, and etc. right from the Microsoft packages. Going further, .NET Aspire. .NET Aspire, it's a framework in the preview from Microsoft that trying to solve the problem of local development. So now, if I'm developing some kind of microservices, I have a huge Docker Compose file with some PowerShell scripts to start all containers together and to test my application with other dependencies. Microsoft trying to solve this and bring seamless experience to Visual Studio. So your favorite F5 debug will start all the containers, all the dependencies, databases, and etc. It's working now, and it's kind of good, but there are some logical obstacles here. So if you already have experience with Kubernetes and you do the Docker compose for yourself, this framework not really helping you because it's a one-time activity. You set up the boilerplate, you prepare the scripts, and then everyone in your team working with the scripts. And another problem here, potential problem, let's say so. Potential problem with this, that it solves the database container for you. But to create the data in this container, you need to write your own factory and service and create, so call it like you will write another boilerplate, but in the C# on behalf of .NET Aspire. And this kind of, I'm not sure if this will really work at big companies that have already Helm charts, Kubernetes, and other stuff. But this will work for the small project, or if you are starting your own startup. So if you're starting with something new on the .NET, I think .NET Aspire is a right fit because it will remove the hassle from you to set up all the microservices that you have. And you can specifically name dependencies, and it will start containers for you. It relies on the Docker. And these components of .NET Aspire is just another new Git package for you. And this solves local developer problem. .NET Aspire also trying to solve a problem of remote deployment, but this is not yet really solved. They're just trying to do this. Integration testing. .NET Aspire, because it can create the containers for you, you can use it also for integration testing on your Azure DevOps pipelines or GitHub Actions. This is also in preview now, and probably it will be released this fall, hopefully. But .NET Aspire, as it abstracts away container and Docker compose from you, all the microservices and dependencies like RabbitMQ, MongoDB, and anything else, you can do a proper not end-to-end testing probably, but integration testing for your code. And integration testing, from my perspective, is really problematic now with distributed systems. And a company that is claiming that everything okay and they don't have issues on the end-to-end testing because developers done the proper integration, they are probably lying about this. Test containers, framework outside of Microsoft, but it's really good for the local development. And this is something generally available. And if you need to solve issues with testing your code and do the proper integration testing for the distributed systems, I highly recommend testcontainers.net. Just try it, and you will like this really, like this very much. Then it's a Radius project. Radius project from Microsoft trying to solve platform engineering problem. So with this project, you can write only with Bicep, unfortunately. So it's JSON infrastructure as code from Microsoft, but you can write a description of your platform and then have just configuration settings for different clouds. So if you build in your .NET project, you can have a description of your infrastructure with Radius code. You can have templates for deployment, and then it's just a different configuration for different environments on different clouds. It's still in the preview, but as I said on the first picture, it's Microsoft trying to attack developer happiness problem with two sides. First with serverless, like functions, container apps, and etc., and .NET framework. And then from the DevOps side. So Radius coming from the DevOps side only, but my take on this that you will see some kind of a Radius abstractions in 1 or 2 years. And it's better to have a look and watch for evolution of this project, at least on the Microsoft stack. Then it's .NET Aspire and Radius project. It's a comparison here. So .NET Aspire, it's just developer-centric and using concrete dependencies. Radius project is for abstracting infrastructure from developer or from any developer team. So it's different responsibilities, and if you probably seen some demos or talks about .NET Type project, it was aimed for the local developers. It's already dead. Microsoft killing products like no one else. But it resulted in .NET Aspire and partially in the Radius project. And we moving forward. It's too much content. I'm sorry for this. Azure Container Apps. They are quite mature now. And if 1 year ago it was just the containers and etc., now it's a lot of stuff. Now the most awaited feature, it was session affinity. So you can have a lot of microservices and your clients can keep sessions connected to the particular instance and particular data set. Another thing, it's scheduled jobs. Scheduled jobs, it's nothing else that cron jobs on the Kubernetes, but it's a good abstraction, and now it's GA, and you can use it. It's reliable, and if you have a lot of scheduled jobs and you're using like PowerShell functions or something like this, you can go with containers. It's called template jobs on the container apps. They are quite good. And container apps, it's actually abstraction over Azure Kubernetes service. Sorry. And my take on this, that in a few years, probably Kubernetes will be the backbone, but most of the developer teams will use some kind of abstractions layer. It can be abstraction layer like open source community, like a Backstage with some orchestration, Jenkins, and etc., or it can be something from native from the Microsoft. But you will see only revisions and core concept of Kubernetes removed from you. So you will not be responsible for patching, for Helm charts, and etc., because this is something AI can generate for you. This is typical architecture. So you can replace Azure Container Apps with Kubernetes without any problems. And the thing is, with Azure Container Apps, it uses these DAPR blocks, distributed application runtime blocks. And so if you started with serverless containers on Azure, it's super easy to migrate to Kubernetes. And I done migration from Kubernetes to container apps, but this is another story. But it's safe to use Azure Container Apps if you want to migrate to full Kubernetes, and if you want to migrate to full Kubernetes on other cloud, like Elastic Kubernetes Service on AWS. So Microsoft is not really locking in you inside the Kubernetes service. So what is serverless and what is Kubernetes? Serverless brings developer-centric to you. So it's you just developing code and you're not solving performance issues in the cloud. It's actually not true, because you still need to know how your application works, how many memory it consumes, and etc. But everyone on serverless talking like you just deploy your code and it's working. It's not entirely true. But if it's a simple CRUD application, it will work. If it's something complicated with CPU memory, even GPU intensive applications, you should go with Kubernetes, because there will be not enough compute on the serverless hosting for you on any cloud. And it's quite limited. And I will show on the last slide about this. Going forward, Azure Container Apps key elements. So it's 2 plans now. Dedicated have a lot of CPU and EOPS power now. So it was consumption before, only 4 processors and 16 gigabytes of RAM. Now on dedicated you can have 64 CPUs per instance, and it can be up to 30 instances. There are different environment profiles. Environment, it's actually just a VNet. It's a virtual network because Azure Container Apps is abstraction over Kubernetes. Then it's revisions, it's just the versions of your service code that you can shuffle and redeploy at will. It will keep about the log of about 100 revisions per each application, and so you can do easy blue-green deployment or canary releases and only allow like 10% of the customers or particular customers to access instance. Jobs, its most awaited feature, and it's now in GA. It's working really fine. And resiliency is in the preview. And resiliency is really a component of the Dapr distributed application runtime framework. And a few minor details. Distributed application runtime. It's also coming from the Microsoft, from the same Azure CTO team that created Radius. Sorry for this. And it's called Open Application Model, the model that you just develop in your code, and you can switch dependencies. So if you can deploy your Dapr application on the Azure Container Apps, then with change of manifests, you can deploy this Azure Container App to the Kubernetes. And from Kubernetes, you can move to any cloud. Because if you're using on Azure Service Bus for the messaging, you can just switch dependency description on the AWS for the SQS or any other message queue. Yeah, it's really working. It's the killer feature, and it's really working. But it's and the case for using Dapr for your application, if you're working with startup, it's that you can use free credits from Azure. It's a bad practice. Don't listen to me. But you can use free credits from Azure, then hope on the free credits of AWS, and then hope on the free credits of Google Cloud. And Dapr can solve this problem for you without rewriting any dependencies or code for the particular infrastructure options on the clouds. What? Yeah. Dapr can be run locally with help of EES web server. It's crazy stuff, but it will not be really good. Okay, resiliency on Dapr. It's a component of the framework, and this is kind of call it resiliency on the Azure Container Apps. You can set up this resiliency with YAML or Helm chart on the Kubernetes, or you can use just a visual configuration on the Azure Container Apps. Dapr components on the Azure Container Apps. The main problem here is that they are not up to date with open source Dapr, that is like cloud agnostic, and they are quite simplified. So on the left, it's a Dapr PubSub component on the Azure Container Apps. On the right, it's a full Dapr component. It's just a component for abstracting the service bus. But it's quite different, so you will not lift one-to-one from the Azure Container Apps to the Kubernetes, but with slight rewrite, ChatGPT knows about these components and manifests, and it will convert it for you. Then you will test and fix the bugs. I mean, everyone doing this right now. So yeah, future of Azure Container Apps is super bright. They're doing a lot of stuff, and they're trying to fix even, they have a holy war actually now about Windows containers. Anyone using Windows containers? Then thanks God. But it's real problem. I mean, banking applications and etc. that done lift and shift, they in really bad situation. I have another word, but yeah. Let's go to the Azure Function. So they claiming that isolated worker model will be from 2026. So there is in process, there is isolated worker on Azure Functions, and isolated means that Azure Functions converts to the simple .NET application. You will not have any difference in the boilerplate or startup of the function and your standard web API. And they're doing this to accommodate this ahead-of-time compilation that I mentioned before. So minimize the bundle, minimize the cold start, and to do this, they need to remove this in-process in process model that is like 80% of applications now. So you will not have this web job startup stuff. Then what is coming next, coming this year, hopefully, flex consumption plan. They're trying to compete with all other clouds, so they will offer on consumption plan more CPU power, network, and instance concurrency setup. So now you can, you know that it's 1.5 gigs of RAM and half of vCPU per each instance, and it's 200 instances on the cheap consumption plan. But you cannot do anything about this. They will solve this problem for you, so you will have more instances and more concurrency. So now host of Azure Functions trying to figure out how many functions can be, instances of function can be deployed per this virtual machine with 1.5 gigs of RAM. But then you will be able to set up this by yourself, test by yourself on the local machine, and understand how much impact your application do on the memory and CPU. And this is why I mentioned serverless do not remove this responsibility from you. You should know how much memory consume your application and how it's working. But now Azure Functions have this publish ready to run option. And this is kind of version of ahead of time compilation to optimize the cold start. So if you have now just a crude application that's just writing and reading the data, you can use publish to ready and experiment with this stuff. But you can get very random results, unfortunately. Then functions can now be deployed on the container apps. It's in the preview. And Dapper extension trigger on the function also available, but it's only available for Azure Container Apps. And the reason for this, Azure Functions seen as a glue between different microservices, some kind of a service-to-service invocation, or maybe integration between different Kubernetes clusters. So they moving this these updates now, and hopefully this year there will be a Dapper trigger on the public instances of functions that is not deployed to the container apps. So Microsoft trying to unify all the .NET boilerplate into the one ecosystem. And what is also going on now, they moving Azure Functions functionality to other services. It's not done like officially, but now Azure App Service that is widely used now have a it's called it's some kind of it's elastic scale or something like this on the App Service. I forgot the name. It was released like two weeks ago into GA elastic scale, and it will scale Azure App Service with HTTP requests. But if you don't know how your application works and it's working with memory optimized stuff, like you loading into the memory some kind of certificates or keeping huge collections, it will not work for you. But you should experiment with everything that Microsoft doing and understand how it's working. So this is why reason I'm emphasizing you need to know memory and CPU impact of your application. Moving forward. So this is the isolated worker startup. It will be standard main file. It will be standard main entry point and program, and then it's just a pluggable services that you can use. So you can essentially in the future can just copy paste your API to the Azure Functions, or copy paste Azure Functions to the web API project and just change some dependencies there. This is the roadmap of Azure Functions, and it was changed several times, and this vertical line was moved already for 2 years at least. Keep this with a grain of salt, but I think the deadline for moving to the out of process and removing the old model from Azure Functions will happen around .NET 10, which will be in 1.5 years. Let's talk about scenarios. And this is a quite complicated question, because I worked with different companies, and most of the developer teams don't want to use serverless because they want a Kubernetes on their CV. Like if you know Kubernetes, it's easier to get a new job, and you have this experience, and you can learn Kubernetes on the budget of your customer, essentially. And this is what many developers doing. Myself also. So yeah, I mean, it's life. And so containerizing legacy applications. Is it doable with Azure Container Apps? Yes, but my take on this, it's better to rewrite them, just copy the C# code to the .NET 8 and change the startup of the code, and do not containerize this. Though this is advertised and this is doable. So if you're thinking about moving old code to the container, you should understand that this is if this is EES code, it can you need a Windows container. And if you need Windows container, you should go to the Kubernetes or Azure Application Service, not to the container apps for now. But people really actively asking for this. If anyone worked with Microsoft Orleans, cool, okay, skipping this. This is Actor framework that is working for many distributed systems, old distributed systems. And Actor framework implemented on the Dapper, and it's available on the container apps and Kubernetes also. Downgrade with simple integration. So what I really done in production is that you're doing the audit of the company, you come in and see the some Kubernetes services in the production, then you open in cluster configuration, there is no auto scale, all fixed size, all cool, like 100 requests per day. This is typical, and or 1,000 requests maybe to the Kubernetes, and it's consuming a lot of money, and they keep in DevOps on the some percentage to keep this running. So Azure Container Apps, it's a good scenario to migrate off Kubernetes simple CRUD services to the container apps and avoid the hassle with supporting it and thinking constantly about patching and about network issues. But this is doable only if you don't have complex network. If you have complex network and integrations with a lot of distributed systems, you should hire a proper DevOps engineer or learn it yourself and stick to the Kubernetes for now. Azure Container Apps have a good integration with network, but you will still need an engineer for this, and some components is really missing. But jobs, it's a good thing. Lifting CPU and memory heavy functions. I've seen durable functions and just a simple function that is running on the function host with limited memory, limited CPU, constant timeouts. I mean, the time for the execution for simple functions on the consumption, it's 10 minutes maximum, and it will be destroyed. Your application will be destroyed in around 9 minutes or something. So if you have long-running functions, please leave them to the Azure Container Apps. It's just a function command to create a container and deploy it there. You will have the same easy experience with local debugging and etc., but you will not have issues with running in production with some kind of timeouts and other stuff. If you have a lot of teams, if you have a complex project and you have Kubernetes, good for you. It's really, really fun. But Azure Container Apps is a good option to create cheap dev stage environments. Because if you have like 9 teams working on the same project, and it's a lot of versioning, a lot of configuration, versioning, and etc., teams can have this environment on the app, on the Azure Container Apps to solve their integration problems, because they don't you don't need complex network like in production. You don't need powerful instances that have a lot of memory and etc. All the load integration test, not load testing also can be done, but integration testing can be done on the Azure Container Apps, and it's really a good scenario for this. And portability to other platforms. As I said, the evolution path is just starting like with Azure Function, then you moving it to container, then container connected with the distributed application runtime, then it's moved to Kubernetes, and from Kubernetes to any other cloud. And this is what a lot of companies now doing. Let's talk about problems. So you will hear that everything works and no problems at all. But it's only if we're talking about the code. If you're talking about application configuration, application versioning, and infrastructure, it's starting to be super problematic, because if you're working without DevOps engineer, or you have a bad DevOps engineer, you just have a Git and everything committed to the Git and instantly deploy it. And most of the teams have issues with this ways of working, because it's always the latest version you have. You don't have previous version, you don't have a forward version. And if you're working with Azure Functions or any serverless or Azure Container Apps, they have version of each service, but they don't have a version combination of different services that you need to match, because it can be different contracts between services, it can be different anything. And this is the thing you need to think about. Another thing is distributed tracing, and now it's mostly done with some different stacks and pluggable code, but this is something .NET Aspire also trying to solve. So if you develop your application with .NET Aspire framework, you will get distributed tracing out of the box. So you will have these pluggable components on each and every service that you have with Aspire. But you will have this huge root of services inside one solution, and someone from junior developers can put a nail to this and just connect you with some services with using. This is the problem with .NET Aspire and mono-solution approach. And there is an alternative open source system. Actually, a lot of big companies with distributed developer teams working with open source. So it's a tool called Tilt, and you have your development environment on the Kubernetes in the cloud. So when you're developing your service, you just hit in F5, and it instantly connected to the Kubernetes in cloud, and you can send requests and just continue development of your service. And Tilt available as part of different platform engineering stacks. Backstage is just a web UI portal for developers to set up a new services. So essentially, platform engineer on the background set up all the boilerplates, writing scripts, and etc. And you just going through the wizard and setting up. I need .NET service of version 6 or 8 for the Azure Container Apps, or Azure Kubernetes, or AWS Kubernetes. And after this flow, you will have a link to the GitHub repo with all boilerplate with all code created, configuration created for you, and instance in the cloud will be created automatically for you as well. And this is the main obstacle, because if you're a small company that working with Microsoft stack, all cool, and Microsoft trying to keep you happy and provide tools for you. But if you're working in a big company, 90% that you will encounter different open source tooling. And last but not least, it's abstractions that you cannot control. For example, you have a Azure Functions SDK of particular version. Version can be anything like 9.1.1. And there can be issue with the next version, .2. And then Microsoft fixing this issue, it will be .3. But you don't know about this because you're not looking into the issues on the GitHub of Azure Functions SDK. And so you're deciding to update, and you bump into the next version. And this version have bug. And you don't know about this. And then you have a magical moments in staging, hopefully, but maybe in production, if everything works, then something isn't working. Something you cannot inject at the runtime, your database, or it's some kind of a managed identity issue, and etc. And you can encounter this a lot of times. So if you're working with serverless, please always know the URL of the GitHub repository of particular SDK like Azure Container Apps and etc. And be ready to look to the issues tab to figure out what is not working. And it's really will take you 5 minutes to have a look what kind of issues people have in there. Because it's not magic, it's some other developers like you developing code for you. And they also making mistakes, and unfortunately no rainbow and no ponies here. And last but not least, serverless containers are really big thing on all clouds. But only Microsoft at the moment, because of the deeper integration, allows you to lift your containers from the container apps to something else without much of the effort. AWS App Runner, it's really limited, and it's kind of the worst of all the serverless containers for now, at least. GCP Cloud Run is actually based on the Knative framework, and if you work it with Kubernetes, you probably seen this framework in different scenarios. And it's most powerful one, and it's most reliable, I would say, GCP Cloud Run. And with this being said, it's all about your happiness. I mean, platform engineering about your happiness, and serverless, it's also about your happiness. So you don't have to bother with anything. You just need to write your code and make your customers happy. But the problem with the happiness is that you don't know how system is working on several levels below. You can figure out this, but you will need to spend some effort. And so it's up to you always to decide, is it a time to go with .NET only, with .NET Aspire, with Radius, with container apps, and etc., or is it time to break free and go to the Kubernetes, write the Helm charts with help of ChatGPT, of course, but do everything on your own. But companies now is actively pushing people to stop using, to stop writing infrastructure, stop writing boilerplate, and etc. And it's two parallel stories. One is serverless, like Azure Container Apps, Functions, and etc., because you can easily use already prepared templates by Microsoft for you, or it's Backstage and other platform engineering tools that you'll need to configure by yourself or by platform engineer. And with this being said, thank you. I'm slightly earlier, so we have a few minutes for the questions. I can switch to the first slide with all the global map, so it will be. When
you have been presented by a code, if we can open the slide.
Yeah, I think so. Yeah,
as I believe if I will run this project, it will pop up all the containers in my local Docker.
Yeah.
And I'm curious about Azure Service Bus. I believe the Service Bus container of Azure, it's not fully supported. It doesn't exist.
It will be.
Is it something new, or is it like a mistake?
It's a bit of the magic here. So no. You can really get this project from the GitHub. But two sides of the story. First, it's .NET Aspire in the preview. It's preview 5. It will be released soon, but it's kind of working now. It's working nice with databases already and some other components. Some components it's not really working very well. And sometimes you need to use, instead of the container that is kind of very unstable, you need to use emulator that is provided like with Azure Functions and etc. But it's expected that with GA it will be fully working. But this is not a quite container. It's just a NuGet package for the Azure Service Bus that builds a container, and it's something is built with from the NuGet package of the Azure Service Bus. To answer fully, you need to just pull this NuGet and have a look what they're doing with. Maybe they on the way to create this container.
If you run it locally, it will not use Service Bus, but it will make RabbitMQ, if I remember correctly, this project. Because I saw it, this is typical Microsoft
it's the Preview 2 or Preview 3. It has an emulator just under the hood. Like it's kind of, oh, it's container, okay, but it's Microsoft emulator of the service bus that you have with Azure Functions. Yes.
I'm slightly confused about what you said about the limitations of native AOT. That you said also in console. As far as I know, you can use Symbuild to create web applications as long as you're going to use reflection.
Yes and no. Why am I mentioning it? They're not recommending to use AOT with serverless apps at the moment. You can use it for minimal web APIs. Now AOT is working, but they not pushing this as a cloud native kind of part. So if you're using minimal web APIs and Chiseled container for the IoT, it will be really small package, and probably it will be good fast scaling on the Azure Container Apps. But since it's kind of they went out, I mean, it was released like 4 months ago. The .NET 4 months or maybe more, but it's freshly released, and it will be probably stable with .NET 9 or .NET 10 for the serverless application in general. So you will have this, you will have this Chiseled containers and a ahead of time compilation right out of the box in the Visual Studio, and this is where they're going. Now, if you want to try AOT and Chiseled container, the lightweight deployment, you can do this with minimal web API application on the .NET 8 only. Any more questions?
This container apps, does it also support load balancing? How it works?
They have a super simple ingress now, like without any external configurations and etc. Out of box. But it's actually it's a Kubernetes with pods, so it's using but it will be balanced on the HTTP request, not on your memory or CPU, and this is the problem. This is why I meant that what I meant, but by you need to know how your application working. What is the memory set, committed set, what is the CPU, and what is the behavior? How many data are you keeping in the memory?
If container consume service bus messages, then there is no HTTP. How
Load balancing working on the KEDA scalars. KEDA, it's part of the Microsoft open source stack. Let me find it. It was not much time to cover anything. Azure Container Apps actually powered by several things. A distributed application runtime for all the external components. If you don't use Dapr with Azure Container Apps, it means that everything done by HTTP scalar. Envoy and KEDA, it's Microsoft open source scalar for Kubernetes. You can use it with Kubernetes. You can use it and it's powered in Azure Container Apps. You just open in the KEDA and see what kind. Azure Container Apps don't have all the scalars because KEDA have scalars for the SQS, for the GCP, and etc. But Container Apps using KEDA scalars for all sorts of PubSub and etc. You don't have access to this, but it will rely on the. If you will see the manifest for the scalars, it will rely on these configurations. And this is the thing with Azure Container Apps. So you see in the black box there and deploying containers, but if you know that it is using Dapr, KEDA, and Envoy, you can see how they will. You can predict how your application will behave. Because if you add in the Dapr, you know that it's a PubSub component that will be using Azure Service Bus or SQS on the AWS or etc. And this way, you can see the configuration of the scalar and understand how it's working. Now you don't have access on the container apps to the Dapr, KEDA, and Envoy. You cannot configure this really. but you have a standard configuration that they have in their GitHub repositories. No questions? Everyone ready to go? Okay, I will be available here, and if you want to chit-chat about this, I have a lot of bad stories about Kubernetes and both about serverless, so thank you for visiting me.